So, week 4, fundamental concepts of statistics. This is the course content of the week. Let's begin with significant digits. So, basically significant digits is the number of digits to the right of the decimal point. That is to say, you see these are the numbers. And here I have, after the comma, I have 1 digit. So the number of significant digits is 1. Here I don't have any number after the comma, so the significant digit is 0. For example, here I have this value, and after the comma I have 1, 2, 3, 4, 5, 6, 7 digits. So the number of significant digits of this value is 7. Okay. So here's the important information. In your undergraduate courses, you have to use 3 significant digits, otherwise, unless otherwise is stated. Okay, so let's say in your homeworks or in your midterms, finals, whatever it is. Let's say you were calculating some distance, for example, and you see this value, for example, in your calculator. So your answers should be in 3 significant digits, right? So you have to write something like this. Okay, even though this is your here this is your value in your calculator, you have to write this answer in your sheet. Okay, so dimension and unit. A dimension is a measurable physical idea. So let's say you have your rod, and one of the measurable physical idea of this rod is length. Okay, so length is a dimension. Also, another measurable physical idea of this rod is mass, right? You can measure mass of this rod too. So, however, the unit is describing how much of that dimension exists in a specific situation. That's to say, like amount of length, for example, could be in meter, or amount of mass could be in kilogram. Okay, so these are your dimensions, and these are your units. Okay, so we have to be precise as engineers. We have to be precise. Okay, so we do not say bake the cake for a time. We do say bake the cake for 35 minutes, or we don't say we need a long rod. We don't say a long rod. We say we need 30-meter rod. Okay, we have to be precise. And metric system. We have talked about this before, but let's talk about it again. So the metric system is also called SI system. It is the system that we are using in Europe or in almost all countries. So here, this is dimension and symbols. For length, you have symbol L. For mass, you have this symbol. And units, which is these are SI units. are here. So dimension length has unit meter and its symbol is this. Okay. We're going to be using this SI system in our engineering life, in our courses. So, like we talked about this before, this is SI units. So we're going to be using for length, for example, meter, not foot. This is in another SI. This is in another unit system, which is American Engineering System, and SI prefixes. So basically, what a prefix is that it is a multiple of 10. For example, let's say I can say 198 thousandths meter, but for easing it, I can just say 198 kilometer. Okay. So this kilo here is a prefix. So how did I convert that? So I can write this like this too, right? Times 3 meter. And here 10 to the 3 is, as you see, kilo. So I can also write it as 198 kilometer. Okay, prefixes are important because it eases our life. So I am advising you to like learn at least these prefixes. Okay, we are going to be using those prefixes in our engineering course, not just for this course, but for other courses too. And notation. So we have scientific notation and we have engineering notation. What are those? Okay. So let's get through the example. So in engineering notation, this is engineering notation. You have exponent m, which is m is a multiple of 3. Okay, this m is multiple of 3. And in the left side here, you can have more than 1 digits. Okay, I have 1, 2, 3 digits, for example. But in scientific notation, this is your exponent. This exponent doesn't have to be multiple of 3. However, your digit on the left side of the comma has to be just 1 digit. You cannot have 3 digits here. You have to have 1 digit if it is a scientific notation. Let's go through the example. You're going to understand it better now. So this is my value here. And you see in engineering notations, here these are your exponents. You see all of these are multiples of 3. And in the left side of the comma, I have maybe 1 digits, but I can also have more than 1 digits. For example, I have 3 digits here on the left side of the comma. However, in scientific notation, here these are my exponents. As you see, those are not has to be multiples of 3. But in the left side of the comma, I have to have only 1 digit. So this is the differences between them, and it is good to know those notations. You're going to need them later. And with prefixes, of course, you can show them easily. So this is mega, for example. What is mega? It has to be 1 to the 6. Okay. Here you see mega. It is not 1 to the 6. I'm sorry, 10 to the 6. Okay. Conversions for units. Okay, we talked about the units. We have SI system. We're going to use SI system for sure, yes. But sometimes we need to convert one unit into another. And for that, we have our tables. For example, here you see 1 kilogram is in pound mass. You can see this as like this. So for example, 1 meter is 328 feet. Okay. Also, this table here, you can see it anytime, but you can just Google it too. It will do your work. We have, well, let's talk about the conversion for fertile. So in the example, what is asking is that I have 123 miles and I want to know how much kilometer does it make. Okay, the question is this. So for that, what you can do is that let me see the table. So here I can use this one. So I know 1 kilometer is equal to this much miles. So I can just divide both sides with this value. And that would give me 1 mile, right? So because this is 1 mile. And this would be giving me, let me see. This would be giving me this much kilometers. So here I found 1 mile. So the question is this. So I just can put mile as, so this is 1 mile, right? As like this. This is how much a mile makes in kilometers. So I want to erase this one. And what it makes is okay. Let's see another example. So in this one, what is asked is I have 2-inch and I want to know how much centimeter does it make. So here I can use this one with table. So I can just write so 2 and how much 1 inch is. It is 2.54 centimeter, right? And that would make 5.08 centimeter. And that is my answer. Let's make another example. So let's say I want to know how much 2-inch squared is equal to in centimeter square. So I have 2-inch square, but I want to know how much centimeter square does it make. So what I'm going to do, so 2-inch, I'm going to place 254 centimeter in the place of inch. And what it makes, it takes the square of it, right? And here, this is going to be my answer. And that is going to be this. So I think this one is easier for you. You can always use this technique here. It uses this technique with proportions, but also what you can do is that you can just place your desired unit in the in the in the units that you want to convert. Okay. Here we have common derived units in the SI system. So we have, for example, for force, we use Newton. This is in SI. So 1 Newton is also equal to kilogram meter per square second square. It is going to be important to know these values, especially you have to know this one, and these four. So these four, please know them, because that we're going to be using them in our course too, in your exam or whatever. You just have to know one force is going to be equal to kilogram meter per second square. Okay. Here we have a table for units conversions. Let's keep going with statistical analysis of experimental data. So we have a problem in measurement, and that is, even though you're doing everything right, you're doing everything the same, two measurements could be different from each other. Let's say you're measuring temperature of a water. Even though you're doing the same thing, two measurements could be different, and this randomness can be caused by uncontrolled variables affecting the measurement or lack of precision in the measurement process. So to be able to suppress this randomness, to be able to express this, we have statistical analysis. So here we have an example. Like, imagine you're measuring the temperature of a hot gas, and you're measuring it 60 times. Okay. And you're going to have different measurements. And here we're going to talk about this. Here we have two different tables, and both are actually the same. Okay, the measurements are same, but the expressions are different. Okay. How to read them? So in this one, in the table on the left, basically what it is that we have total of 60 measurements. Okay. And let's say for 1105 degrees Celsius, we had 4 measurements. Okay. And for 1095 Celsius, we have 4 measurements. So that is to say, I made 60 measurements, and 2 of them was 1094 Celsius. 9 of them was 1120 Celsius. Okay, this is how to read this one. Here we have another graph which is for to help us visualize the data better. Basically, how do we read them is that we have an interval here, as you see. Okay, this is bin interval, and it corresponds to this interval, right? And how many measurements do I have in total in this interval? I think I have like 25. No, I have 25 measurements. No, 23 measurements. And see, it corresponds to 23. Okay. This is how to read these histograms, this graphs. Here I have another one. This one works with intervals. Basically, what it is that in between 1085 Celsius and 1090 Celsius, I have only one measurements. And I have another type. This is the frequency occurrence. It is like almost the same. Actually, they are same. Okay. Let's keep going with central tendency. So we have measurements for measurements of central tendency. What is it? What does it supposed to mean? So let's say you have this graph, right? And you want to know how your center is tends. So imagine something like this. And you want to know where is your center. You want to express your center. Okay. That's why here we have measures of a central tendency. We have mean. Mean is basically the one we are using the most. It is taking the average, honestly. Just we have this one and this one. Both are means, but this one is for finite number of elements. Okay. Basically, what you're doing is that you're just summing the measurements and dividing it to the total number of measurements. We have median and mode. We're going to talk about them in a real example. And we have measures of dispersion. So we have deviation. What is deviation? So di, for example, let's say I measured all my measurements. I had 60 measurements, for example, and I took the average of it, and it turned out 13 Celsius, for example. This is my average, right? Okay. So di is, let's say, xi, the ith measurement is 10 Celsius. So di is equal to, which is deviation, 10 minus 12, it is minus 3 Celsius. Okay. This is deviation. Then we have the mean deviation, which is basically the mean of your deviation. Okay, it's the averages of the deviation, but please care, we have this absolute bracket here, so the result should be in positive. And we have standard deviation. Which is expressed with this formula. You're going to understand it better in the real examples that we're going to solve. Here we have an example. Okay. So I made 1, 2, 3, 4, 5, 6, 7 measurements, and here these are my measurements. Okay. So how do we calculate the mean? We're just summing the measurements, and we just divide it by the total element number, which was 7. Okay. This is how you calculate mean. And for median, you're putting the data in an order which it is increasing order. okay? And for median, you're taking the center value, okay? You have three values on the left, you have three values on the right, and in the middle you have your median, okay? This is your median, which is 3. Okay? This is how you find your median. If it was odd, let's say, okay, let me erase this one and give you another example. Let's say you had 7 on the left. So you have now total of 8 measurements, which is even. Then you have like 4 on the left and 4 on the right. And what is my median? In that case, what you're going to do is that you're going to take these two numbers, you're going to sum them and divide by 2, which you're just taking the average, and that would be again 3, which is your median. Okay, if your total measurements number is even, this is how you're calculating your median. Keep going. For calculating mode, so basically the mode is the most repeating number, okay, in the sequence. So I have 3 times 3, and here I have 1 1 2 1, no, 1 1 1 2 1 4 1 5, but I have 3 3. So my mode is 3 because it is the number, the value that is repeated the most. For calculating variance, so here this is your example. In the square root, here it is calculated variance, okay? Here this is variance. If you take the square root of your variance, it will be equal to your standard deviation, okay? Basically, this is your formula. You're just using it. So your average, your mean is calculated before, right? What was that? It was 3, right? We calculated our mean here as 3. So here, this is 3. And what is my n? N is the total number of measurements, which it was 7, right? And xi is the ith element measurements, okay? So second measurement is 2, and fourth measurement is 3, for example. You're just taking the differences, so you're just taking the deviations, that is to say, and you're taking the square of them, and you're after that you're summing each element, then divided by the number of elements minus 1. And here this is your variance, and you're just taking the square root of it, and this is your standard deviation. Here we had 60, remember we had 60 measurements of temperature data. Here these are the statistic values, okay? Here these are for Excel. So you can calculate these statistical values by hand, or you can just use Excel for it. And we're going to talk about Excel a little bit. Okay. We have an histogram example. So it is told how to build an histogram. So what is histogram? This is an histogram. Okay, it's a type of graph, you can say. So let's say you have your table 1, table 2. You have your measurements, and you want to build an histogram, and you want to know how to build it. Here it is how you do it. So in step 1, you have to determine the number of bins. What are bins? Here we have 1 bin, 2 bin, 3, 4, 5, 6, 7, 8 bin. Okay, this is your bins. And to be determine the number of bins, you're just taking square root of number of data points, and you're going to round it to a whole number. Let's say in this example, you have 23 students, and you're measuring the heights of them. So your total measurements are 23, right? And you're just taking the square root of 23, and it is equal to 4.9. And you're just going to round that up, which is 5. And here, this is your total number of bin. This is step 1. And for step 2, you have to determine your range. What is range? It is basically x max minus x min. So the tallest person is 75 inches, and the smallest person is 64 inches. You made 23 measurements, and the differences between them is 11 inches. So here, this is your range. And then in step 3, you just have to calculate your bin size. What is bin size? Here, this is your bin size, okay? In this example, the bin size is 2. Okay. So how do you calculate your bin size? Here, basically, you have your range, okay? You have your range. And you have your number of bins, right? You have your number of bins. And if you divide them like this, and after that, if you round it, you're gonna find your bin size. So what was my range? It was 12, right? And what was my number of bins? Here in step 1, I calculated it. It was 5. And so it is equal to 2.2, right? Is it 2.2? Yep. Okay. So you're just going to round it, and let's say round it to the 2. Okay. And here, this is your bin size. And after that, you can build your histogram. Here on the left, this one, the one we were building. But notice here the bin size is 3. You can always change your bin size, okay? If you take your bin size as 3, so in step 3 we have calculated bin size, right? The one way to do it is this, but you can always change your bin size, and you can just say, oh, no, I'm just going to make it 3, and according to that your histogram will change. Here the bin size is 4 and histogram is changed, okay? Basically what is happening is that as you're increasing your bin size, your values here has to be bigger. Okay, here it was 9, for example, right? But here it is 10 because your interval is getting wider, and therefore your number of measurements should be higher. Here we have another example. We have a set of data. This is first set, second, third, and fourth. You're just remember what was mean. You're just taking the average of them, and median is the number in the middle. Okay. Here I have 3 measurements on the left, 3 measurements on the right, and the middle one is median. Here, this one is you can calculate the mean just by summing them and then taking the average of them. And when you're calculating your median, you have 2 measurements on the left, you have 2 measurements on the right, and I have nothing on the center. So what I'm going to do is that I'm just going to sum these two and take the average of them, which is 50 plus 70 and divided by 2, which is 60. Okay. Here I have another one, another example. Remember what this one was telling me? It was telling me that I had total of 23 measurements, and for example, 4 of them was 7:1, and 3 of them was 6:8, and none of them was 62, and etc. So for calculating the mean, what you're going to do is that you're going to multiply these two and write it here. You're going to multiply these two and write it here. Multiply these two and write it here. And you're just going to sum them here. This is going to be your total sum, but you just calculate it here as this amount of inches. Then you're just going to take the average of it. That is, I mean, you're going to divide it by the number of total students, which it was 23. Okay. And it is happens to be 16.9 inches. To calculate median, you have to write it down from the little and to the biggest to the most, and you're just going to take the number in the middle, okay, which is 70. So I have 12 measurements here. No, sorry, I have 11 measurements here, and I have another 11 measurements here, and in the middle I have 70, which is the mean. Yeah, sorry, the median. To calculate variance, remember you were taking the differences, you were calculating the major deviations, and you're going to take the square root of them, and you're going to divide it by the number of elements minus 1. Here, this is your variance. And for standard deviation, you're just taking the square root of it. Okay, this is variance, this is standard deviation. In example 5, I'm just going to leave it to you, but here this is how you solve it. The same thing, the same procedures goes, just leaving it to you to solve it by on your own. Okay. I have another example. I'm just going to leave it to you, solve it on your own. So assignment of the week is that please solve these problems on your own. Now we are going to talk about Excel a little bit. I'm just going to show it how to do these statistical measurements in Excel with a computer program. Okay. All right, let's talk about Excel a little bit. So we can use Excel for calculating some statistical measurements. So remember our example one, which it was this. At first, I'm just going to give the numbers here. We have 7 measurements, okay? And I'm just going to write our measurements. So the first one was 1. The fourth measurements was 3, okay? I'm just going to write it down here as like this. And I'm just going to take the sum here. I have a formula here as like this, okay? It's in Turkish, but it works, okay? It is summing between C2, this is C2, to the C8, okay? This is how we do it. And after that, you're taking mean of it. How do you taking the mean of it? In this block, I have C9 over B8. C9 divided by B8. So this is C9, okay? So it is the sum. So what is BA? This is B8. Here, this is B8. So the sum of the measurements are divided by total number of measurements. So it is the mean, right? So here it is the mean. For median in this block, we have already formula. You're just using this formula. So it is ortanca, and you're taking you're giving in this parenthesis your interval, which is C2 to C8. Okay. And you can write your deviations like this. How do we do that? So in this block, for example, I just took the differences, okay? And here you're taking so in this block, what it does is that I know my average is 3. Okay, I calculated my averages as 3 here. And what was deviation? It was the measurements minus average. So C2, this block minus the average, which is 3, is giving me the deviation of the first block, second block, third block, and it goes like this. Okay, and here in this one, I'm just taking the square root of it. So this is D2, and square root of D2 block is 4, and it goes like this. And here in this block, I'm taking the sum of them. So for standard deviation, remember the formula. Okay, this is standard deviation formula, right? So what I'm going to do is that I'm just going to take E9, which is this is E9, which is sum of the standard deviations plus square root of them, of course. And I'm just going to take I'm just going to divide it by this. Okay. Then what was B8? This is B8, but I'm just going to have to divide it by B8 minus 1. Okay. Here, this is B8, now minus 1. And I'm just going to take the square root of it. So here, this is the square root. And you see this square root formula here. And that would be equal to my standard deviation. For variance, I'm just going to take square root of it, right? Here, that was in E12, I have my standard deviation, and if I just take the square root of it, it will be equal to my variance. And for mode, I have this formula. Okay. Again, I'm giving my interval here. This is my interval, and this is my formula. You can use this one to calculate mode. Here we have the other example. Remember the other example that we were talking about, the temperature of a hot gas. Here I wrote it like this. But for understanding it's better, for making our calculations easier, we can also write it like this. Okay, this is the same set of measurements, same 6 measurements, but this is in more detail. Okay, so how did we read this? How did we read this tables? Remember, so this is number of reading, right? Okay. So for I made 60 measurements and 2 of them was 11, 15. And I multiplied these two and I found this one. And after that, I summed them and it was my summation. And I divided my summation to do B15, which is this block, which is the number of samples. And that would be equal to my mean, okay? Here, this is how I calculate my mean. Another way to do it, I'm going to put it in more detailed version like this. Okay, I have 60 measurements in total. All right, and then I'm just going to sum them here with this formula, which is deviation square. Okay, here this is my average. Remember, we talked about how to calculate averages, the formula. And this is my median. Here, this is median formula. This is your mode. Okay, this is your mode formula. And for standard deviation, I have this. Okay, I'm just using the same example, same formula here. And for variance, I have this. Okay, so even if your number of total samples are, let's say, 1,000, you can use Excel and get easier solutions rather than just doing it by hand. But however, to learn it, you have to do it on your own with your hand, okay, to be able to use the formulas. And after that, you can always use Excel to imply better and easier solutions. Okay. See you next week.